This video is an introduction and demonstration of the Deer Harvest Mapper tool designed by Ethan Jackson, Evan Klauda, and Bo Yao. We will start with an overview of background information about deer harvests and the New Hampshire Fish and Game Department, then proceed into the purpose of the tool and relevant work, continue on to a discussion about the tool and future considerations, and then finally conclude with a demonstration of the Deer Harvest Mapper tool. The New Hampshire Fish and Game Department states its mission as a partnership with the public to conserve, manage, and protect resources and their habitats, inform and educate the public about those resources, and provide the public with opportunities to use and appreciate those resources. This tool aims to provide a better means to satisfy this mission statement. Deer harvest numbers are closely documented and analyzed every year to determine future hunting policies. The New Hampshire Fish and Game Department publishes annual harvest reports that document each year's harvest and policy changes. This tool is targeted at the biologists and policymakers at the New Hampshire Fish and Game Department. It aims to support exploratory geovisualization through the use of highly interactive and visual analysis tools. The goal is to provide policymakers with a better tool to analyze deer harvest numbers. We categorized relevant work to our tool into three topics: space-time visualization, coordinated multi-view visualization, and usability. Challenges present themselves in space-time visualization when animation is incorporated. Challenges such as disappearance can be solved with methods such as manual stepping and visual benchmarks. The operational task typology can be used to evaluate the robustness of tools that use spatiotemporal data. Andrienko et al. Combines the previous work of three others to come up with this typology. Search targets, search levels, and cognitive operations can be combined in the form of questions in order to evaluate the functionality of a tool. Coordinated and multi-view visualization relates to the tool having multiple views that are linked and show different perspectives of the information. To enhance these views, others have discussed making traditional methods interactive. The visual information seeking mantra discusses having an overview and then drilling down into the data to obtain more information. The usability of our tool is an important aspect we kept in mind throughout the development. Usability heuristics have been designed as rules of thumb for creating a usable interface. These heuristics suggest useful components of an interface and how they should be implemented. This is a screenshot of the Deer Harvest Mapper. It consists of a map, line graph, animation controls, filtering options, and an interactive legend. Each component will be covered in detail during the demonstration. The Deer Harvest Mapper aims to provide New Hampshire Fish and Game Department policymakers with tools to visually explore harvest data in order to aid in knowledge discovery. Future considerations include implementing a dedicated view that shows a comparative breakdown of gender and hunting type. Currently, this is not shown as explicitly as it could be. Additionally, formal evaluations using end users would improve the tool's usability and utility. This is the interface of the Deer Harvest Mapper. The central view is a map of New Hampshire delineated by wildlife management units, commonly called WMUs. On the map are proportional symbols based on harvest counts. The map view allows the user to gain an overview of data along with spatial reference. Regions of higher counts can easily be identified in this view. The symbols aggregate harvest counts based on the selected filter options. The filter options include gender and hunting type. These are the same categories that are reported in the annual harvest reports. The filter options can be turned on and off, and the two views will reflect this selection. When two or more filter options are selected, the counts are added together and displayed. At least one gender and one hunting type must be selected. If none are selected, no data is displayed, and an indicator appears alerting the user of this. The interactive legend provides the user with controls to change what is shown on the map. The symbols can be colored based on percent change from the previous year. These colors can be turned off if desired. Benchmarks can be applied to the map to address the issue of disappearance during animation. The benchmarks show maximum, minimum, and the previous year's value for each WMU. Below the benchmarks are representative symbols and their values that can be used for quick comparison between the legend and the map. Below that is the symbol size slider, which enables the user to scale the size of the map symbols. This is to address the wide range of values that can be represented. For example, if only youth hunting is chosen, the symbols become too small to see. The slider rectifies that issue. The slider is limited in how large it can scale the symbols. When the maximum symbol size has been reached, an indicator appears to inform the user of this. Details on demand can be obtained on mouse over of either the map or the line graph. The user can choose to view a simple label as shown or choose to display the full details. The full details include a histogram showing harvest numbers for that particular WMU over time. Additionally, the harvest count for the current year and the exact % change from the previous year are shown. All of these numbers are based on the filter options that are currently selected. Also, notice the linking between the map and the line graph when a WMU is highlighted. The map can be animated to show trends over time. Standard VCR controls are provided to start the animation, stop the animation, step forward, and step backward through the years at a desired pace. Additionally, a slider is provided under the line graph, allowing another input device for navigating through the years. The line graph view shows all WMUs plotted along the same axes. The bottom axis represents time, while the side axis represents harvest numbers. The side axis is scaled based on the selected filter options so that the full height of the line graph is always used. This view allows for easy comparison between WMUs over time. For example, looking at only youth hunting, the line graph shows a single WMU that is far above all other WMUs in harvest numbers. Mousing over the line shows that this pattern belongs to WMUD and is highlighted on the map. Information about the tool is located in the bottom right-hand corner. The data source behind this tool can also be accessed from here as well. Each component of the tool has a question mark next to it that can be clicked on to access more information about the component. This has been an overview and demonstration of the Deer Harvest Mapper. Thank you.